Welcome to this 2024 Vectric user group meeting on the triumphs and pitfalls of AI. In this session, we're hopefully going to cover how we can use AI tools to augment our existing CNC workflows. So in this session, we're going to be covering 5 key topics. The first one is the generation of design ideas. So how can we use these AI tools for inspiration or as the start of a project? Then we're going to look at creating and editing vector graphics, and we're going to see how we could use these with standard toolpaths in Aspire and VCarve Pro. Then we'll look at editing images, so specifically removing backgrounds, removing watermarks, artifacts, things like that. And then finally, we're going to move to producing height maps. So how can we use these image generators to generate height maps, and then how can we use those height maps within Aspire? So how can we take them and generate real usable 3D models? So let's talk a little bit first about our main characters. There are so many of these new AI tools. They're popping up all the time. Probably if you're watching this presentation a year from now, there'll be a whole new set of them. But for now, we're going to go with the big ones. So ChatGPT, which is probably the kind of most famous chatbot out there, the one that's most popular. And it has an image generator, DALL-E, so we'll be kind of using that as well. There's Claude from Anthropic, and that's a really kind of powerful chatbot that's used effectively to kind of give more thoughtful responses. That's how it's kind of known in the industry. And finally, we're going to use Adobe's Firefly, which I think is less popular, but it's kind of more relevant to what we're doing because it's kind of designed for creative professionals. So let's start by talking about large language models and what they are. I'm going to use this phrase, large language models, because that's the kind of basis for what all of the new technology is based on. And whilst it's not strictly necessary for us to know how these things work, if we do know how they work, then it can be helpful, because then when things don't work as we expect, we can kind of adjust our behavior to counteract those things. So firstly, we won't go into a lot of detail, we won't go deep into the technical weeds, but we'll give a kind of really brief overview. So firstly, they are trained on vast amounts of data, books, articles, a huge chunk of the written internet. So these tools are trained by kind of hoovering up all of our information and processing it. And then what their task, the task that they're given is to predict the next word. So they're kind of like very fancy autocomplete tools. They will read in all the data and they'll just predict the next word. But they'll do so in such a convincing way that they'll generate a kind of coherent response. And they do this by analyzing all of the data in the context of the whole thing. So they're very good at recognizing patterns of things which are separate in sentences and stuff like that. So they don't just use the little bit of knowledge they know, they use all of the knowledge they know. The underlying technology is a kind of neural network, which is a sort of simulation of a human brain. So we imagine this whole network of agents with different kind of properties to them. And as they're trained, they strengthen the connections between the nodes based on what the outputs are. So you give it an input, it gives you an output, and then you adjust your neural network to see if you can get a better output. So you adjust the strength of the connections. So it's got all these kind of dials, knobs and parameters. And the number of parameters is important for generating the complexity of the results. So in the case of the large language models, the large signifies that these tools have lots of parameters, in some cases up to kind of 80 billion. And once they've learned how to do this, they respond by generating responses. And it's kind of important to know this because, again, they are just giving the next best word. They're trained to give the next best word. So it's not real intelligence. And what that means for us in our industry is that, one, they can be overconfident. So they'll say stuff that isn't true, but they'll be sure it is. And two, they lack the subtlety of understanding to know that this might be a precise piece of work we're doing, and good enough is not the right answer. So it's important to bear that in mind. We shouldn't just accept their responses on face value. But they are always improving. If we look at the results now versus 2 years ago, they are massively improved, and they'll continue to improve. So what does this mean for us? Well, first of all, they're very useful in design because, as shown, they can produce very interesting results, but they do have some kind of key limitations, and that is they don't really understand or have taste. They're not up to date with style, and a lot of the time they're kind of just aping the designs that they've seen before. So they struggle with kind of truly novel concepts. To give you kind of a good example of this, my son, he's into dragons, and so we were trying to generate dragons, and he was asking one of these tools to generate a kind of wingless dragon. And no matter how hard you ask, no matter how many times you say no, without wings, please, it will generate you a dragon with wings. And although we don't know exactly why, we can probably assume that the reason is because, as far as it's concerned, dragons do have wings. And so this is a very key limitation for us, because if we want to generate novel things, then it might struggle. And it's why we should consider them to be tools for augmenting design processes, not replacing them. We don't get rid of designers, we'll actually need them. The other big problem they have is style consistency, and you'll see that a little bit later on. These tools are kind of generating things over and over from random. And so if you want to produce things of the same style, you need to be very, very precise about what that style is. And even then, you can't guarantee that it's going to maintain the style across your whole design process. So it's just something to bear in mind. So whilst these large language models are really effective at dealing with text, what they can't do is see. They have no concept of images. They may appear to see, but they are just analyzing patterns in data. And what they also can't do is generate images. So they can generate text, but not images. And this is where we have to turn to another tool, which is diffusion models or diffusion algorithms. You'll probably have seen these things. This is where you have some kind of prompt. So you're seeing here, this is DALL-E from OpenAI, and you give it some kind of text. We're asking for a photorealistic image of a chinchilla here, and it's going to go away and it's going to generate this image. And these are probably the tools that we'll end up using more in our day-to-day work. So again, it's a good idea to just have a very brief idea of how they work. Sometimes they generate amazing images. Here's this chinchilla in a hat. But also you can see that sometimes they don't give you quite what you expect. They can generate slightly unusual, even if they look kind of coherent results. So let's just go briefly into how they work. Mostly because it's actually a really fascinating topic. So imagine you have loads of images, and what you want to do is you want to add some noise to them. So what we do is kind of progressively add noise to these images. And we're going to train an AI using this neural network architecture. We're going to train an AI to figure out how much noise is in the picture and how to remove the noise. And this is a kind of task that's easy to do because you've got a huge training set, and you can kind of algorithmically add the noise and train them without any human interaction. So we're going to do this, and we're going to train this AI by adding noise and figuring out how much noise is in the image. And finally, at the end, you've got this great tool for removing noise. But then the magic here is, what happens if you just give it noise? So if we start with just noise, you can then remove noise. And using your tool, if you take pure noise and remove noise, what you end up with is a coherent image. So you've trained something to generate images. And these were the kind of very earliest form of these image generators. Things like, this is not a real face, for example, where it just generates photorealistic images of faces, but they're not real. They're just trained on these kind of, on the basis of removing noise. What you then do is you kind of add text, and once you've added text, then you are able to attach this metadata, and finally you can say, oh, I'm going to be able to generate an image of a chinchilla, and it will know. And the maths and the computing there is much harder, but still it's fundamentally the same idea. So these are really effective tools for generating images, but again, they have some issues. So as with the text tools, they lack precision, They have this style consistency problem that we spoke about earlier. They have resolution limitations, so often because of the way they work, they're working on kind of pixels. So what you can't do is make them give you a really massive image, although we'll talk about later how you can use AI tools for that. There's potential copyright issues. So because of the training data that they've used, we don't really know whether or not we might get something that's a copyright problem. They try really hard to prevent you from generating things that are copyrighted too, which sometimes can interfere if you're not intentionally trying to breach copyright, but they're still preventing you from generating the image you like. And finally, there's the kind of text to image gap. So this is almost a kind of human problem, which is how do we, as humans, describe the images that we want? And in part, that's quite a difficult thing. So if you want to describe an image very precisely, then you need to give these tools very precise instructions. So how can we use these image generators? Well, we can use them for inspiration. We can have access to a whole vast array of data. And so if you're asking for ideas for, say, children's signs or signage for a business, then it's going to be brilliant. Logos, anything like that is going to give you ideas straight off the bat. We can generate vectors for tracing. You can get them to generate SVGs, but we mostly will be using them for tracing in Aspire and VCarve. We can get them to generate photos, which again could be used for, say, sketch carving or laser engraving. And we can get them to modify images. So we can get them to remove watermarks or remove, say, people from the backgrounds of images that we don't want there. And finally, we're going to use them for generating height maps. So in our next session, what we're going to look at is how we can use these to generate vectors for, say, V-carving or sketch carving. And the key thing here is going to be about prompting. So how can we prompt these tools to give us the results that we like? So firstly, we are going to start simple. If you look at any of these guides, and there are a few out there that are really good. The one from Anthropic is really good. It goes into a lot of detail about how you can get the most out of their specific tool, things like adding weighting and things like that. But those guides, they are kind of emphasizing the complex side of things. But I think it's always useful to start simple, mostly because they're iterative tools. So if you are using them effectively, then you're going to have to probably prompt them a few times to get the right result. And so it's a good idea to just start as simple as possible and then build on that. On that basis, I think it's good if you start with a selection, because that way you're going to help with this text to prompt gap. So this idea that you don't exactly know how to describe what you want. So what you want to do is maybe generate a few things and take one of them and use that as the basis for your kind of ongoing work. And one tool that I think is really, really effective here is Adobe's Firefly. So like I said before, it's designed for creative professionals, and so it's targeted very specifically at generating certain types of image. They have this nice feature where you can adjust the intensity of the output, and what that really seems to do, although we don't exactly know because they're kind of black boxes, but what that seems to do is kind of adjust the detail of the image that you're getting. So in our case, let's say we're doing V-carving or sketch carving, this is a really useful tool because we can kind of adjust the detail and make it a shorter carving or a longer carving or something more appropriate for our machining constraints. Next, we should be specific. So they respond very well to being given very precise instructions. If you kind of leave room for them to maneuver, I suppose, then you have less control over the results that you're going to get. So it's always good to kind of give the most precise instructions that you can once you know what it is that you want. And one specific way of doing that is by employing negative prompts. So these are cases where what you really want to do is you want to say you don't want something. So that could be, I don't want, in this case, I said I don't want a name on this generated child door sign, because when I was generating them originally, then it actually just put the word child as the name, which obviously is not right. Some common, I guess, negative prompts would be things like, I don't want a background, I don't want the sky, I don't want any texture in my image, that sort of stuff. I think there are some tools, so Stability AI, they have a tool which actually allows you to kind of put the negative prompt in as a separate parameter and then it's weighted differently. But otherwise, just put it in the main prompt. I do not want this. It shouldn't have these features. Then we should include technical specifications. So again, this is, I guess, a follow-on from being precise. In the case where we're trying to get vectors for, say, V-carving or anything like that, then maybe we would want to specify that these lines should be used for tracing. So we'd be perhaps be asking for, say, clear lines, no interior vectors, made of simple shapes, that sort of stuff. No gradients, anything that will, again, help to constrain the image generation. Always consider that they are iterative tools. So you're going to generate an image probably that you don't like originally, but then we can work with that to say, no, make it more like this, add this detail, that sort of thing. Some of them, so this is an image from DALL-E, some of them have tools inside them that mean that you can kind of select areas and say, edit this, remove that. Here what I've done is I've kind of just selected some regions and said, remove these bits of the generated image because I didn't want them. That's a really useful feature. And finally, I think this is probably the one prompting tip which I think is the most useful of all of the ones, and that's asking the actual tools for help. Since they are now kind of trained on today's data, what they also have is a very good knowledge of how you prompt one of these tools. So here's an image from Adobe's Firefly, and you can see it's actually suggesting prompts, suggesting ways in which you can generate the right type of image. I think one other useful tool is asking, say, how would I prompt for this? That works really well in some specific cases, and we'll see that later. There's one particular case of using the AI to help where I think this is really useful, and that's using your own designs as inputs. So here I've got this image. It's a letter, it's a W, it's kind of made of floral elements. And let's suppose this was given to me by a customer, or I'd drawn it myself and I wanted to do a whole alphabet of them. Perhaps it was scanned from a book, something like that. But I want more of these letters. I want a letter S, say. How can I get from that image to a new letter? And this is our process that will work. So some tools you can just give them. So OpenAI, ChatGPT, you can give the image and you can say, generate me a letter that looks like this. I would say that often that doesn't work very well because they can't see particularly well. So they will see patterns in the data and they'll get something right. They'll recognize that there's a flower or things like that, but they don't really understand the tone or the subtlety in what you're asking. So this process that I'm going to describe now is perhaps a bit more flexible. So the first thing you want to do is ask the AI to look at the image and suggest a prompt. And the reason we're going to do that is because we can then use that as a stable thing to build from. So what I do, I go here and I go to Claude and I say, look at this image. Can you describe a prompt for me that will generate this? And the reason I'm using Claude here is, one, I think it's actually a really good tool. It seems to give very thoughtful responses, but also it helps to distinguish between the two different modes we're using. You could just do this with one tool if you only have one. So it suggested a prompt for me that I'm then going to take and I will feed that into ChatGPT. So I'll take that prompt, I feed it into ChatGPT. ChatGPT will generate me an image. And now it's time for me to use my artistic judgment. So I would look at this image and I will see what it is about this that I don't like. The things or the elements that make it not match. So in this case, it's generated something right. A floral S, it looks kind of roughly right, but it's not perfect. It's too busy. It has kind of too much weight in the S. So I feed that back now. So I'm going to feed that back into Claude. I'm going to say, it's generated me something, but it doesn't look kind of quite quite what I expect. So I think here I'm going to say it doesn't leave enough negative space in the S. It's a bit too busy, that sort of thing. And what Claude will then do, it will adjust its prompt, and it has the context, so it knows what was asked before. It will adjust its prompt, and I'm going to get a new prompt out of it, which I can then feed back into ChatGPT, and we continue. So this emphasizes again what I was saying before, that these processes are kind of iterative. So you see, it's given me a prompt, and now I'm going to copy and paste that into ChatGPT, and it's going to go away and generate a new image. And if we skip ahead a little bit, this middle image here now, that's the one I got after the second, and we can see it's pretty good. So the W on the left is my original, the S in the middle is the one after 2 attempts, and I do a couple more attempts and I'm kind of left with an S that actually looks right for me. So like I said, I think it's quite an effective result, and just asking the AI for helpful prompts, I think in general is a really useful thing. If you're already using existing kind of photo editing software like Photoshop or Affinity Photo, then you'll know it's probably pretty quick for you to remove backgrounds on images. However, there are now new AI tools which have been specifically trained for this task. And so if you don't already have access to those tools, or you just want a kind of one-shot, simple to use tool, then these are really effective. So let's just go into Aspire and we'll have a look at a simple example of something where we could remove the background, and we'll show how we can use this tool to remove the background and get the result that we want. So here's a file that I have, and I'm just going to go into the simulation, and I'm going to preview the job that we have. And what I've done here is I've got some V-carving, I've got a profile, and in the middle I'm using this technique where we do sketch carving and photo V-carving to get kind of a nice textured image of this dog here. But the image itself is a bit noisy, there's a lot going on in the background, and so what about if I just want to focus on the dog, on little Rex here, and not worry so much about all of the noise. One tool I can use is this tool from Adobe, which is their free AI background remover. All you do is you just go in, you select your image. So I'm taking my original image of the dog, I upload it, it does work for just a few seconds, removes the background, and you can download it. So like I said, it's one shot. You probably have access to some of these tools, maybe if you're using existing photo editing software, but this works really well. It's free, and I would recommend it. The results are really good. And if we go back into Aspire, I can open up my my job from after this. And again, we'll preview all the toolpaths. It's the same toolpath, just recalculated with the new image. So let's go and preview them all. And now you'll see the image itself has been trimmed, and we've just got this focus on the dog. Okay, so our final application here of AI is for the generation of reliefs. And I think everything that we've done up until now has been building up to this. So what is the process that we're going to use to generate these reliefs? There are tools, I should say straight away, that will generate 3D models, but they are usually full 3D models, which is not really what we want in our kind of CNC world, and also they tend not to be very good. So what we're going to do is we're going to focus on generating these kind of relief style models. And the process we're going to use is this. We're going to generate an image of our desired result. We're then going to use an AI tool to generate the height map from the image, and then we're going to combine that height map with detail in Aspire to get the resulting relief. And a little bit more detail, we'll generate the image of the desired result. We're going to upscale it using a new AI tool, because we'll need better results than the AI tool can generate for our subsequent steps. We're going to generate the height map from the image. We're going to then remove sort of imperfections using the tilt and fade and the replace below tool. And then we're going to, again, combine those models in Aspire. So this is the image that we plan to create. It's a kind of relief of a sunflower. And I want to talk a little bit about the prompt that we use to generate this image, because I think it ties back nicely to what we discussed earlier. So this is the prompt. As you can see, it's pretty enormous. And I want to just focus on it because I think it shows you the sort of thing that eventually you'll have to provide. And the way I did this, the way I got to this prompt, is actually using an existing prompt. So there's some really great videos already on using AI tools to generate 3D reliefs. I took a prompt from one of those tools, from one of those talks, and then I fed that into my AI, so into Claude, and I said, this is a prompt that works well for me. Can you perhaps suggest improvements? Can you give me specific ways in which I can make it better? And here are some things I noticed. First of all, it's very good at focusing on the details. You'll see it says it needs to occupy a certain percentage of the image. It specifies the numbers of things, although I would always be careful because mostly they can't count these tools. And it also gives a kind of stylistic advice. So here it says Art Nouveau style. Notice a negative prompt, design with no undercuts. Again, it's not so obedient because there are a few undercuts, but on the whole, it's reduced those compared to, say, a full 3D model. And then there's the technical specifications. So you'll see specific detail about lighting. It's asking for kind of 4 distinct depths of levels. Again, be careful because they can't count, but still it's specifying a number of distinct levels of depth and the 3D effect. And also here it's said minimum feature size of 2.5 mil for feasibility. So this goes back to what we were saying earlier about giving instructions that are relevant for the application. And this is the final result. It's this kind of nice 3D relief of a sunflower. And I think we can see that there's going to be some work to do here. There's a kind of unusual border around the outside. But if we had that 3D model, that would be a really impressive result to get out. So how are we going to take that image and get the 3D model? And the way we're going to do that is by generating a height map. I do want to stress actually first, before we get to that this technique works really well, not just on a very narrow example. Here's a load of different images that I've been able to generate, and the process that I'm going to follow next, I've done with all of these ones, and you managed to generate interesting and I guess I'd say useful models from them. Some of them don't work as well. So you'll see there's this kind of hockey player. That one doesn't work as well because perhaps it's not so organic. And so perhaps this technique works really well for more organic shapes than not. But nonetheless, it's a technique that doesn't just work on a kind of artificially fabricated example. So yeah, firstly, what we're going to do to generate a height map is upscale the image. Now, our image in question came from an AI tool, and because of that, it's got a relatively small number of pixels. Now, the way Aspire works is when you generate a model from an image, it's going to try and use the number of pixels in the image as the number of pixels in the model. Roughly, there will be some kind of minima or maxima, but roughly that's the way it works. And using a low number of pixels can mean that we generate models which feel blurry or kind of slightly furry. So in our case, what we want to do is we want to just add some more pixels. And this turns out to be a tool that, or a task that AI is really good at, because they can kind of infer the boundaries between like the already existing pixels. So let's go to the browser. I'm going to go to this image upscaling tool. So this is on Hugging Face, which is a kind of, I guess, a marketplace, or a place where people share their kind of AI experiments, and there's this really nice image upscaling one, and all you do is you just drag and drop your image. So if I were to drag my image into here, you choose a model. Here you've got x2, x225 and x4. X4 is basically times 4, so you're going to get a massive number of pixels. I think you can get away with kind of any of these bottom two, but it's up to you. And you just submit. Now, you can end up in a queue because of the way this is free. If you pay, obviously, then you jump the queue, but it doesn't take too long. Here it kind of predicts roughly about 8 to 10 seconds. But what we'll do is we'll let that work, and we've got this model that we've already made earlier. And we've already upscaled this image. So this is the kind of resulting upscale image that we see here. And we're going to then use that to feed our next stage. So the next stage of this process is generating a height map. We want to take our image and see if we can detect the heights. Now, if you've ever done this before, you can import any image into Aspire to generate a 3D model. But what you find is you get something that looks quite unusual sometimes, because what we're using is the luminosity of the pixel, the luminance of the pixel, in order to determine the height. And that's not always a very good way of, I guess, describing the depth of something. So we're going to use another tool to detect the heights. And again, this is a task that an AI has been specifically trained for. And these tools, I guess, are improving all the time. So the one that we're going to use is something called Zoe Depth, which happened to come out, I think, in 2003. But there are new ones now like Marigold and Patch Fusion, which are also really effective, and we'll touch on them in a bit. So what we'll do next is go to the browser, and I'll show you how you can generate the height map from an existing image using a kind of free tool. So now we're back in the browser. We're going to go to our other tab here, and we're going to use this tiled Zoe Depth Colab. So Google Colab is a place where you can run AI experiments, and by and large, it's free. Again, it's got the same process where if you overuse it, you'll end up in a queue. So you may want to pay if this is part of your, I guess, production workflow. And what we want to do here is we're just going to connect, and that's going to connect us to a computer. And we can actually look in the drop down and it'll tell us what kind of computer. By default, this is set up to use something called a T4. And this T4 is effectively the graphics card description of what the computer is. And it just means that you can run this bit of code really quickly. You can run this locally, and in fact, we have a version here that is running locally, but because of the kind of computers they're running then, and the kind of graphics card requirements, you might find that it's quicker to just use these tools online. And all you do then is you just run the code. You'll be warned that this is someone else's code, and you run it, and you'll be asked to choose your file. You select the image, so we'll input our image, and then it's going to go away, it's going to run, and eventually it's going to give you back the height map. So in our case, this is the height map that we get. And as you can see here, light colors mean close to us, dark is further away, and it's done a reasonably good job. It's managed to pick out some of the really high points. There's some slight peculiarities, but on the whole, it's been really effective. And what we'll do next is we'll talk about how we can then use that in Aspire. So let's just make a new job, and I'm going to make it 24 inches square. OpenAI's ChatGPT and DALL-E, they generate square images by default, so our model will be square. And I'm going to set the resolution here to be very high, the modeling resolution, and that's just because I want to preserve as many of the pixels of the generated image as possible. So I'll hit OK. And then I'm going to use this tool at the top, the create a component from a selected bitmap tool. So we will come in here and we'll select the depth, and we'll import that. And if we go to the 3D view, we'll see that the model has imported, but unfortunately, it's enormous. So we're going to use the T shortcut key here to go into the set size tool, and we're going to just set the size here to be 22 inches. And the reason we're doing that is I kind of just want to give a little bit of a border around the outside of my 24-inch job. Hit apply, and it's generated, but it's now off the screen, so I'm just going to kind of drag and drop that into the center of my job. And we'll see here, when we look at this in the 3D view, that the model looks pretty good, but it doesn't quite, I guess, have the detail that we would like. So it's preserved the heights really well in general, but it doesn't have any kind of the fine parts of the leaves. The swirl is a bit washed out. And there's some other things about the model that are kind of slightly unusual too. So if I just make the model a bit thicker and then kind of view it in profile, you'll see that it's actually sort of slanted. And when you think about this, this kind of makes sense, because what that really means is that the back of the model appears to be further away. So the top of the model appears to be further away. And that makes sense because these AIs are trained on things where the top of an image is the background, so you'd actually expect it to be further away. But that's not what we want here. So what we're going to have to do is do something to kind of level that out. And the tool that we obviously want to use here is the tilt and fade tool. And you can do this from within the 3D view. We can come and select this kind of options. We're going to use tilt, and we're going to set a tilt across from bottom to top. And then we'll just adjust slightly the parameter. And we'll do this all by eye really. So you'll see as I do that, it's kind of lifting the back side of the model up. I'm just going to kind of lowering it down somewhere around there. Again, if we look at it from this view, we'll see we've kind of got it right. I might actually want to add in a specific value, perhaps just to tilt maybe a bit more, just to get it up so it's all even. And that roughly is right, I think. So our model now has at least looks flat now, but it has all this weight behind it because all the detail is still on the top. So what we're going to want to do is just chop out all of what's underneath the top layer of detail. And the way we'll do that is with the replace below tool. So if we go to replace below here, if you've not used this tool, it has a kind of sliding plane, and as the plane moves up and down, it shows you the areas that are going to get sliced. So you'll see as we drop through, we're going to kind of remove all the detail. And I'm just going to kind of push this plane down until I can't really see anything anymore. And then I will replace it with the transparent and lower it. So what that means is really like we're slicing out the bottom and the whole of the detail of the model drops. Hit apply. And you can see the effect that had. So now our model is much thinner and we don't have this kind of artificial base height in our model. And we can still do things like adjust the heights within the 3D view. Okay, as we said before, the problem now is that we don't really have too much detail. So what I want to do is add that detail back in. And the way we're going to add the detail back in is actually import our original image. So let's create a component again from an image. And now we'll take the original image. It will look horrible for a second because we need to again scale this. So we'll set the height and the width to be 22 inches, just like before. And we'll also move that back so it's in the middle of the job. And now it's overlaid on top of our depths. So let's just look in the component tree and we'll see we have the sunflower, which is the detail, and the sunflower depths, which is the kind of organic mass. And we will now play with them. So I can kind of lower and raise the detail level just by tweaking this little option here. And what's nice about doing this in Aspire is that you get that's like live updating. So you get a good feel for how the detail is being applied. So this makes it sort of easy for us to just tweak little things. And I can do a similar thing here with the depths. So I can adjust the depths as well as the detail and get those two in balance. And once I'm kind of broadly happy with those things, perhaps I want just a little bit more detail, then I guess we're kind of good to go with our model. Now, we notice there are another, I guess, couple of interesting things. We've got this border around the outside, which we probably want to get rid of. Whilst I'm updating and tweaking my model, what I don't want to do is do anything destructive. So I don't want to just trim the outside, because that's a kind of destructive operation that loses the, I guess, loses some of the dynamism that we have. So I'm going to use the option within the level to trim the boundary. So let's just go and draw a rectangle, and I'm just going to draw it roughly across where I want to trim, and then within the component tree I'm going to right click, I'm going to the clipping mode and hit apply, and what that's going to do is take that original rectangle that we've just drawn, and it's going to clip the model to that. If I move my models around, it will just move the clipped 3D model. And so that's pretty much the result we want. Our original one had a border, so we could add that back in. And the way we might want to do that is by adding a new level. And the reason I want to add a new level is I want the kind of border to merge in with the rest of the model. So I'm going to set the combine mode of the level to be merge. And then within the 2D view, I'm just going to kind of create the vectors for my border, select my my original vector, and I'm going to hold down Control and Shift, and I'm going to just drag a little bit in. And what that's going to do is kind of make an inner boundary, and then I'm going to drag a little bit out on the new vector. And that's going to kind of make the outer boundary for this border that we're making. And we go to the 3D view, and with those two vectors selected, I'm going to go to the flat shape tool, and I'm just going to raise up this shape like so to give us the kind of border that we had in our original model. And you can see now we've generated the 3D relief. All of this is kind of dynamic, so we can adjust it to kind of give us the result that we want. And all of that just came from a text prompt, which is, I think, really impressive. Today we've explored the intersection of AI and CNC. Hopefully we've seen that these tools can be used to augment our existing techniques. They can generate interesting vectors. They can inspire us to do things perhaps that we didn't feel were in our tool set. And I guess they've opened up new possibilities for us. I'd encourage you to kind of have a play with these tools and watch them as over the next few years they grow and adapt and become, I think, integral parts of our toolkit. Thank you for listening.